So, welcome you all for another presentation on this network analysis subject. In today's presentation, I would like to explain about the super mesh concept or the super mesh analysis, how the super mesh analysis will be applied to the any given electrical network. For example, consider this is a simple example consisting different resistors and then one voltage source in which we have a 6 ampere current source also. So how this simple given circuit will be solved using super mesh analysis. Okay. So remember that very important point to note down is that how the super mesh analysis will be applied for the given circuit, that we have to identify first. Remember, for this given simple circuit, we have two meshes. Okay, so in the first mesh, current I1 is flowing. This is the second mesh in which I2 is flowing, right? Either this can be called as the first loop or the first mesh, as well as this is called the second loop or the second mesh, right? In the first loop, so current I1 is flowing in this direction, as well as current I2 is flowing in this direction in the second mesh. However, for these two loops or two meshes, 6 ampere current source is a common between I1 and I2, or between the first loop and then second loop. So, the fundamental principle to remember is that whenever a current source like this is given or is connected between two meshes or two loops, so then we can remove this current source. Okay, we have to remove first this current source, then the remaining entire electrical circuit we have to apply the KVL equation, right? That is the step one actually, right? So to apply this super mesh analysis, we have we have to identify that whether is there any common current source between two meshes or not, that we have to identify. So for this given simple problem, we have 6 amperes current source which is a common between both the meshes. Therefore in the step 1, so in the solution part, so in the step 1 what we have to write, what we have to write. Okay, remove the step 1 is nothing but remove the 6 ampere current source from the circuit. 6 ampere current source must be removed. Once you remove this current source from here, automatically your 2 ohm resistor is also ineffective. Means that what, the total branch, whatever the branch is shown here, that entire will be removed from this. Therefore this entire part will be removed from this, right? This dotted line. Therefore if I remove this part, then the resultant circuit will be like this. So that is the first step we have to do. Therefore remove that 6 ampere current source, then you have, this is the circuit now, resultant circuit. So this is the total circuit now. And also the step 1, this is the step 1 in which we have removed the 6 ampere current source. Okay, so along with this 6 ampere, the 2 ohm resistor will also disconnected, because once we remove this, there is no meaning of using the 2 ohm resistor. Automatically that will also be disconnected. Now that is step 1. Now coming to the step 2. What is the step 2? So the resultant circuit we have to identify. The resultant circuit will be redrawn. The resultant circuit will be redrawn as I already shown here. And also you have to show the mesh currents like this. Okay, so in the first loop I1 is there, and in the second loop I2 is there. Therefore that is the step 2. So in the step 2 you have to redraw the actual given problem after removing that current source, common current source, and by identifying the individual currents in their respective loops. Therefore, I1 is the current flowing in the first loop, I2 is the current flowing in the second loop, right? Now, for this circuit, that is the step 2 actually, okay? Redrawing the resultant circuit with identifying the individual current loops, currents I1, I2. And now, what is the step 3? Step 3 is nothing but write the KVL equation to this entire circuit. If you apply the KVL to this entire circuit, how I can write? Very simple. So write this. It is 20 is equal to, for this overall circuit, we have to apply the KVL. What is that? So 20 is equal to, I can write 6 times I1, 6 I1, is it not? Because this 6 ohm is there in the first mesh itself. Therefore, I1 is the current flowing in the first mesh. Therefore, 6 into I1 plus, now coming to this 10 ohm resistor, this is there in the second loop and the I2 is the current flowing in the second loop. Therefore, 10 into I2, right? 10 into I2 plus 4 into I2. This is the overall equation we have to write. Right, this is the overall equation we have to write. So here I can remove this circuit, I can erase this for time being, and I can uh, note down the expression here. So I can rewrite here the equation. It is 20 is equal to, how I can write, 6I1 plus, it is 10I2 plus, and then 4I2, right? This is the overall KVL equation, and further this can be simplified as 20 is equal to, it is 6I1 plus 10I2 plus 4I2. How much? It is 14I2. Clear? So then this you can call it as equation number 1. You can call it as equation number 1. Alright, very simple. You can call this expression as equation number 1. And if you see the original actual circuit, which is given in the problem, so here if you remember there, this is 2 ohm resistor and then this is the current source, 6 ampere is shown like this, and this is the another branch. So this is the first mesh actually, in which the current I1 is flowing like this, and this is the actually 6 ampere current flowing to this node, and I2 is going out from this node. Okay, so what I mean to say is that, so from this current source you can apply KCL here. At this node you have to apply KCL here, okay, for that common branch current source. So if you apply that KCL here, from this current direction you can write the expression for I1 plus 6 amperes is equal to I2. This is the expression you can get actually, because I1 is the current entering at this node, 6 ampere current is also entering at this node, I2 is leaving from that node. Therefore, entering current, sum of entering current is equal to sum of leaving current. Therefore, I1 plus 6 is equal to I2. This is the another expression you have to use. That is the another expression, right? So, by using these two expressions 1 and 2, you will get the currents, respective currents I1 and I2, right? What we can do now, simply substitute equation number 2 in equation number 1, because you know I2 value from equation number 2. Therefore you can substitute equation number 2. So by substituting, you can write like this. By substituting equation 2 in equation 1, then what you will get, wherever I2 is there here in equation number 1, wherever I2 is there, in place of I2 you write I1 plus 6 here, because I2 is equal to I1 plus 6. Therefore, from the first equation you will get 20 is equal to 6 times I1 plus 14 times, what is your I2? I2 is nothing but 6 plus I1. 6 plus I1. And further, if you can simplify that equation as like this, okay, so you can simplify this. This is equal to 20 is equal to 6I1 plus 14 into 6. It is 84 plus 14 into I1. Clear? This further simplifies as 20 is equal to 6I1 and 14I1. It is 20I1, is it not? Plus 84. and this implies you can write as it is 20. You can bring this minus 84 here left side. It is equal to 20 times I1. Clear? And then what you will get actually from this, what you will get, it is something minus 64 is equal to 20 times I1. This implies I1 is equal to minus 64 by 20. It is something, how much it is? So 2 tens are 2, 32s are, it is minus 32 by 10 or nothing but minus 3.2 amperes. This is your current. Therefore, your I1 is equal to, I am writing here, I1 is equal to minus 3.2 amperes. This is I1. You can call it as something equation number 3. Right? So, we got equation number value for I1, that is minus 3.2 amperes. Now, substitute this I1 value minus 3.2, which is there in equation number 3, you can substitute it here in this equation number 2. Substitute this I1 value here, you will get your I2. Therefore, you can write by substituting the value of I1, by substituting equation number 3 in equation number 2, then what you will get, I2 is equal to it is 6 plus I1, this is equal to 6 minus 3.2, it is something you will get 2.8 amperes, you will get 2.8 amperes. Therefore your I2 is equal to how much? 2.8 amperes. So this is what your answer. So this is what your I1 value and this is what your I2 value. Fine. So this is how we have to apply the super mesh analysis for the given circuit in order to find out the current I1 and I2. It's very simple. So simply we have to identify that is there any common current source is given in the given circuit. Okay, if it is given, then we have to disconnect that and we have to consider the entire part as a common circuit. For that, for the entire circuit, we have to apply KVL. That is the first step. And the second step is that by considering at that particular node, we have to write that KCL equation, Kirchhoff current law, you will get another equation. So by simplifying these two equations, we will get the respective currents. Okay, this is what about the super mesh analysis. I hope you understood well, and we'll continue some more examples on this mesh analysis, using the super mesh concept, okay, in our subsequent classes. Thank you very much.